And we're back. Now, in this particular example, we actually covered test hint 10 and 11. Question 10 and 11 will be about two different reactions, but you do exactly the same thing to figure it out. Identify the oxidation numbers on each of the elements, figure out which one became more positive, which one became more negative. Same process, you're just going to have different elements to consider. And that takes us to all of the short answer questions.
We're already there. It's just question 12 and we're already into the short answer.
Right.
There's a light at the end of the tunnel.
Right. Well, I don't know. Sometimes they look at those as the dark at the end of the tunnel.
Yes.
But, so in our short answer questions, the first three, 12, 13, and 14, are going to ask you to do the same thing for three different compounds. So we're going to give you a couple examples, and we're covering test hint 12, 13, and 14 all in one here. And we're asking you to write the oxidation half reaction and the reduction half reaction for three different compounds. Our first example is going to be magnesium bromide.
So we have magnesium bromide. And we give you this formula.
Right.
You don't have to know that formula. It would probably be nice if you knew the formulas for the elements.
Well, yeah.
But you can probably, well, no, you really can't get by without it. How did magnesium, well, first of all, what kind of chemical compound is this? This is just review for the final exam.
Well, I see a metal there
Yes.
and a non-metal.
Yes.
So that's got to be ionic.
Right. So if this is ionic, we have two different ions. We have a cation present, we have an anion present. If you take a look, you go, magnesium started out as regular old happy magnesium.
Right.
What was its charge when it was happy magnesium?
0.
It had a 0 oxidation number. And then something happened to it for it to enter this ionic compound. And when magnesium becomes an ion, it forms positive 2 cations. Now, what happened to magnesium? Actually, I think we had this on the board once already.
I think we did, yeah.
Yes. It releases 2 electrons. Now, yes, you have to give it a little bit of energy, ionization energy, but it will release 2 electrons. Magnesium's oxidation number went from 0 to positive 2 because it lost electrons. Which half reaction did we just do?
Loss of electrons is oxidation,
Yes.
so that's oxidation.
So this is oxidation. And on the other side of this compound, you have bromine. And again, just focus on one bromide ion at a time. You have bromine, Br, and we know that it starts out neutral.
Right. I think you could even write it as Br2
Yeah,
because
okay.
they know their magic 7.
Sure.
And they know that that's an element, by itself it's going to be diatomic.
This also brings us back around to that other question
Right.
that we did a little foreshadowing on way back earlier in the first clip. Okay, so we have Br2, we have 2 bromine atoms, each one of them is neutral, and in this process, they turn into bromide ions with a -1 charge. They're halogens, they have 7 valence electrons, they want to gain 1. So each one of them becomes a -1 ion.
Now, how did it do that?
It
had
absorbed electrons.
Absorbed an electron, took in an electron, gained an electron.
Absorbed an
So
electron.
where is it?
Well, do we want to show that
I
each
think
of
we should show
these?
them too, because
So we have each of these, because there's 2 of them,
Mhm.
because it's diatomic, it's one of
Right.
the magic 7. Each one absorbed an electron. So if you had 2 atoms, each absorbing 1 electron,
we're going to get 2 bromide ions.
we're going to produce 2 separate bromide ions.
Now, take a look back up here, because you probably started thinking about this just when you saw the MgBr2. You might have thought, oh, magnesium's +2, bromines -1 times 2, that's how I'm going to get this thing to cancel out to 0. And look what happened to our electrons here. 2 came out, 2 went in.
This was our reduction half reaction, where we were gaining electrons.
Right.
Grr. Right? And the electrons that are lost are the ones that are gained, and just to tie this back
Back to the
around,
beginning.
this goes back to number 3, which we had mentioned back then. Electrons lost are the ones that are gained.
Ones that are gained. So let's do another example. And our next example is going to be a different compound, but same process. Let's do strontium sulfide. SRS, just because it's fun to write. Now, if I said to you, Mr. Sustin, here's strontium sulfide, here's its formula, what are the oxidation numbers of strontium and sulfur?
I immediately go straight to the periodic table because I know this is a metal and this is a non-metal, which means this is an ionic compound.
Right.
So their oxidation numbers are equal to their ionic charges, and they've got to be pretty predictable because I study all weekend long. So I look at the periodic table, and way over here, the alkali metal section is strontium. It has 2 valence electrons.
Alkaline earth.
Oh yeah, sorry. Alkaline earth. Sorry, I didn't study that. So this is an alkaline earth metal. It has 2 valence electrons. It's going to lose them both and become a +2 ion.
Right.
Sulfur over here is in oxygen's family. It has 6 valence electrons. It wants to gain 2 to satisfy its octet, and it's going to get a -2 charge.
Okay, so when we're asking you to write the oxidation and reduction half reactions, use that and just write it in equation form. So let's start with our strontium, just because it's the first. Strontium would have what?
Does the positive one always come first?
Why, yes.
Okay.
Yes, it does,
I'm just noting that.
because we might need that in the future.
Yes.
Okay, so strontium has something happen to it to go from the normal atom, the stable element, and then to turn it into a strontium ion with a +2 charge, +2 oxidation state. Well, I see neutral on this side, and I see positive on this side, and I know from conservation laws that I need to have things match. So something else must have happened over here. Something else got kicked out, and that was the 2 electrons that strontium lost from its outer shell. Of course, we're not writing the energy here. Ionization energy went in to cause this to happen. And because I'm ending up with my electrons on the product side, they're coming out, they're being lost, that has to be an oxidation reaction.
You betcha.
Okay? Then we always know that, or we know that these always happen simultaneously. Oxidation and reduction are tied together. Something's going to happen to that sulfur to make it become reduced. Well, sulfur's going from 0, the element by itself, to this -2 ion, which means it had to gain 2 electrons. So we need to show those 2 electrons being added in on the reactant side of the equation. Double foreshadowing there.
Yes.
And this is our reduction equation.
You bet.
You may or may not remember, guys, that energy comes out in that process. So you're going to have actually 3 questions like this, but following this same kind of process.